Hello everybody, we are Group 2 from International Class A, Perencanaan Strategis Sistem Informasi, Trisakti School of Management. In this occasion, we will present our final project with the title Strategic Information System on AI and IoT-based Central Kitchen for Big-Scale Catering Production Optimization. Before we are going to the material, let us introduce ourselves. My name is Jennyfer Gunadi with student ID 2024-5002.
My name is Elicia Angelica with student ID 2024-5004.
My name is Elicia Angelica with an ID of 2024-5007.
And my name is Lavienna Oktaviani with the student ID 2024-522.
Alright, let's go to the chapter 1, which is the introduction of our project. Let's imagine that we are running a massive catering business. Like in this project, we are taking example from PT Nova Kitchen. Imagine that we have to prepare thousands of healthy meals every single day. Now, it is not just about making the food taste good. We have to measure calories perfectly, keep portion sizes exactly the same, and make sure everything is 100% clean and hygienic. If we do all of this manually, it is a nightmare. The risk of human error is high, food can easily get contaminated, and a lot of ingredients end up in the trash. Not to mention, hiring that much manual labor is incredibly expensive. So, how do we fix this? The answer is technology. We are proposing a strategy to build a central kitchen powered by AI and IoT. To put it simply, AI will be used to predict exactly how many meals need to be cooked, so we do not waste any ingredients. And IoT, our smart sensors, will automatically monitor storage temperatures and make sure weighing scales are always 100% accurate. On top of that, automated machines will handle cutting and packaging, minimizing human contact, so the food stays perfectly safe and clean. This is exactly why we conducted this study titled Strategic Information System on AI and IoT-based Central Kitchen for Big-Scale Catering Production Optimization. And to guide our research, we have formulated 4 key questions that we aim to answer. First, what is the role of strategic information systems in supporting the optimization of production processes in central kitchens? Second, how can the application of AI and IoT technologies help improve the efficiency, accuracy, and quality of large-scale catering production? Third, how can an appropriate information system strategy be planned to support the transformation of central kitchens into more automated, integrated, and sustainable production systems? And finally, the fourth, what are the long-term strategic benefits that companies can derive from implementing AI and IoT-based central kitchens? To answer those questions, the purpose of our research is divided into 4 main objectives. First, we will analyze the need for an information system strategy that can support central kitchen business processes. Second, we want to explain the role of AI and IoT in improving production optimization, quality control, and operational decision making. Third, we will design a relevant information system strategy to support digital transformation in a large scale catering company. And fourth, we aim to explain the benefits of implementing this strategic information system for operational efficiency, competitive advantage, and company sustainability. Ultimately, we want to help companies like PT Nova Kitchen reduce operational costs, eliminate waste, and support long-term business sustainability.
Okay, next we move on to the benefit of the research. This research has to demonstrate the application of strategic information system planning in large-scale catering and the role of AI, IoT, and automation in supporting business strategy. And another benefit is to help improve production efficiency, product quality, and the competitiveness while reducing the operational cost and raw material cost. The next benefit is to support digital transformation, profitability, food safety, and environmental sustainability in central kitchen operation. Next, we will go to the scope of the research. This research focuses on strategic information system planning for a large-scale catering company, particularly in optimizing the central kitchen production using AI and IoT technologies. The discussions includes the demands for catering, inventory monitoring, temperature control, grammage measurement, production planning, quality control, and operation sustainable production optimization. The paper consists of chapter 1, which is discussing about the introduction that includes the background research problem, objectives, benefits, scopes, and the paper structure. As for chapter 2, we will explain about the theoretical foundation related to the strategic information system, AI, IoT, central kitchen, and the production optimization. As for the chapter 3, we will present the methodology, business analysis, and the design of the AI and IoT-based information system strategy. And finally, for the chapter 4, it will contain the conclusion and the recommendation. Next is the chapter 2, the literature review.
Okay, first of all, let's talk about what an information system actually is. In simple terms, it is not just about technology. It is a combination of technology and people's activities working together to support business processes and decision making. To make it work, an information system relies on 6 core components working in harmony: hardware, software, people, procedures, and finally, network and data. When these 6 components work together, they do not just help with daily paperwork. They drastically improve operational efficiency and help management make smarter, faster decisions. Now, how does this apply to PT Nova Kitchen? An information system helps the company transform raw operational data into valuable insights. Management can use it to track and manage almost everything from customer orders, raw material inventory, and production schedule to labor needs and cost reports. Why is this so critical? Because without an integrated information system, a big catering company faces huge risks. We are talking about errors in production planning, massive ingredient waste, inaccurate food weight, production delays, and ultimately unhappy customers. So, an information system is basically the backbone that keeps the entire kitchen running smoothly.
Okay, so now let's go to the strategic information system. A strategic information system is an information system that supports an organization in achieving its strategic goals and gaining a competitive advantage. Unlike system that only focuses on daily operation, SIS helps organization improve long-term business performance by aligning business strategies with information technology strategies. A strategic information system transforms data into valuable strategic insights through several types of information system. First is the transaction processing system that collects and processes operational data from daily activities. Next, management information system convert this data into useful information for managers. Then, decision support system analyze the information and assist managers in making decisions. Finally, executive information systems provide executive with strategies, insights that support long-term planning and business direction. In catering company, a strategic information system can integrate data from customer orders, inventory, production activities, food quality monitoring, and production costs. By combining this information, managers can make better decisions regarding production, planning, inventory management, and quality control. As a result, the company can increase operational efficiency, reduce food waste and costs, maintaining consistent food quality, improve customer satisfaction, and strengthen its competitive advantage in the catering industry.
Next, we will move on to the artificial intelligence. So artificial intelligence is a technology that enables computer system to perform tasks that usually need to human intelligence, such as analyzing data, recognizing patterns, making predictions, and support decision making. Most AI applications used in business today are categorized as the artificial narrow intelligence or ANI, which is designed to perform specific tasks efficiently. Some AI systems also apply the concept of limited memory machines, where the decisions are made based on program rules and previous data or experiences. In business, AI is widely used for demand forecasting, process automation, operational optimization, and data analysis. AI can identify patterns from historical data and generate prediction or recommendations that help organizations make faster and more accurate decisions. According to Gartner's AI maturity models, the organization progressed through five stages of AI adoption, that is awareness, active, operational, systematic, and transformational. In the awareness stage, AI is only discussed conceptually, while in the active stage, companies begin pilot projects and experimentation. At the operational stage, AI projects are implemented in actual business process. In the systematic stage, AI becomes integrated across organizational and supply chain operation. And in the transformational stage, AI is fully embedded into all business process and digital strategies. This model helps organizations evaluate their readiness and plan AI implementations systematically. In large-scale catering business like the Nova Kitchen, AI can be used to predict customer demand based on historical orders, consumption trends, seasonal patterns, and even schedules. The result can help companies determine the amount of raw materials needed, production capacity, and daily production schedules. This helps to reduce the overproduction, food waste, and inventory shortages. By integrating AI with the IoT or Internet of Things, technology in a central kitchen system, companies can monitor production and storage condition in real time, improve the operational efficiency, maintain food quality, and support better production planning. The implementation of AI is in the project reflects the operational and systematic stages of AI maturity, where AI supports production process and becomes integrated with overall operational management.
After discussing artificial intelligence, we now move to the second main technology in this project, which is the Internet of Things or IoT. IoT refers to the technology that connects physical device to the internet, so they can collect, send, receive, and exchange data automatically. In simple terms, IoT allows machines, sensors, and equipment to communicate data without depending fully on manual checking. There are two main types of IoT: consumer IoT and industrial IoT. Consumer IoT is used in our daily life, like the smartwatch, home device, and security cameras. In this project, the focus is on the industrial IoT because it is used to support production and operational control in the central kitchen. In Perencanaan kitchen central kitchen, IoT can be used to monitor storage temperature, raw material conditions, machine performance, energy usage, food weight, and real time. This is important because catering production depends on the freshness, hygiene, and consistent portion standards. By using IoT, the company can reduce manual monitoring, detect early problems, maintain food quality, reduce waste, support better production planning, and this all helps transform the kitchen from a conventional operational facility into a smart central kitchen. So can you imagine if a cold storage temperature rise during the night and no staff checks it until the morning? The expensive raw materials is damaged. But with IoT sensors, the system can send an alarm and alert immediately when the temperature becomes unsafe, so the team can respond before the spoilage occurs. And after understanding how IoT supports real-time monitoring, we'll now discuss the central kitchen concept, which is the main operational area where AI and IoT are applied.
A central kitchen is a centralized facility used for large-scale food production and distribution. By centralizing production activities, companies can maintain consistent food quality, reduce production costs, and improve operational efficiency. However, managing a central kitchen also presents challenges, particularly in the production planning, quality control, and coordination between different departments. These challenges become more significant as production volume increases. To address this issue, the company can implement an AI and IoT based smart central kitchen. AI helps analyze data and improve production planning, while IoT enables real-time monitoring of inventory and production process. Together, these technologies support automated quality control and more efficient operations. As a result, the company can increase efficiency, reduce waste, and improve overall business performance.
Okay, next we move on to the enterprise resource planning. So the enterprise resource planning, or ERP, is a system used by organizations to integrate and manage daily business operation through a unified platform. ERP combines various business functions such as finance, accounting, inventory management, human resources, supply chain management, customer relationship management, and production into one integrated system. This integration helps organizations improve efficiency, reduce operational costs, and support faster and more accurate decision making. The core feature of ERP is a shared database that allows different departments to access the same real information. This reduces the risk of data duplications, improves the coordination between departments, and enable automated reporting and business processes. ERP systems also provide dashboards and reporting tools that help management monitor key performance indicator or KPIs and overall operational performance. In large-scale catering business, the ERP can support central kitchen operation by integrating the purchasing, inventory, production, scheduling, distribution, finance, and customer order management into a single system. For example, customer order can automatically update production plan, raw material requirement, and inventory levels. This helps the company improve production efficiency, minimize the food waste, and ensure timely delivery. In this proposed AI and IoT-based central kitchen system, ERP functions as the main operational platform that connects AI forecasting system, IoT sensors, inventory management, and production activities. The integration of ERP with AI and IoT technologies enables real-time monitoring, automated data processing, and better coordination across the catering supply chain. Although ERP implementation offers many benefits, it can also be complex and risky if not planned properly. Successful ERP implementation requires strong management support, clear business objectives, employee training, and effective change management. Therefore, organizations must carefully plan ERP adoption to ensure the system aligns with operational needs and business goals.
Okay, let's talk about the supply chain management or SCM. In simple terms, supply chain management is all about managing how materials, data, and payments flow efficiently from the suppliers all the way to the final consumer. In the food industry, this covers everything from buying raw ingredients, storing them properly, production, packaging, and distribution to strict quality control. To optimize a business, every supply chain management system must manage three key flows. First, the material flow. This is the physical movement of goods like fresh vegetables or meat from the supplier right into our kitchen. Second, the information flow. This is the exchange of detailed data among everyone in the chain, such as order updates, customer info, and delivery status. Third, the financial flow. This handles the money, such as billing schedules, credit terms, and electronic payments. Now, why is supply chain management a massive challenge for large-scale catering companies? Because food ingredients are perishable. They can spoil very easily. Any delay in shipping, unexpected price change, or poor storage conditions will instantly ruin the food quality and disrupt the whole production. To solve this, companies use an supply chain management system, a smart software that connects everyone involved. And in our research, we take this system to the next level by integrating it with an AI and IoT. AI steps into forecast exactly how many raw materials we need based on customer demand, so we will not overbuy. While the IoT, we use smart sensors to monitor storage conditions like fridge temperatures and track materials movements in real time. By combining the supply chain management with AI and IoT, companies can completely avoid the risk of running out of stock, overstocking, or having an expensive ingredients go bad.
After discussing supply chain management, we now move to
Decision Support System.
or DSS, which helps management makes better operational decisions. A DSS is an interactive information system that helps organization make decisions using data, models, and analysis. In this project, DSS is important.
Central Kitchen Management.
Must make many daily decisions such as how many portions to produce, which menu combinations, how much raw material we need, and how production schedule should be arranged. And in Petinova Kitchen, a DSS can support portion planning by using data from orders, inventory, capacity of production, and raw materials availability. Instead of just relying on our staff's estimation, managers can use system-generated analysis to make decisions that are more accurate and objective. An AI-powered DSS provides stronger support because it can analyze historical data, demand trends, capacity of productions, and etc. It can also help evaluate efficiency and recommend better alternatives. These SS can also be used for a scenario simulation. For example, management can analyze what may happen if raw material price increase. This allows company to prepare decisions before problems become serious. For example, if the price of chicken increase, the DSS can help management prepare alternatives such as adjusting the composition of our menu, changing the supply quantities, modifying our plans, and this helps company control costs.
Without reducing our food quality.
The next concept we need to understand is business process reengineering or BPR. BPR is a radical redesign of core business processes. The keyword here, the keyword here is radical, which means we are not just making small minor tweaks. We are completely changing how things are done to achieve dramatic improvements in productivity, speed, and quality. Ultimately, the goal of BPR is very clear: to eliminate unnecessary, non-value added steps and to simplify and automate the remaining processes. By doing this, a company can significantly cut down cycle time, labor requirements, and operational costs. In this study, BPR is highly relevant because implementing AI and IoT is not just about buying new shiny technology. It completely transforms how the company operates. Think about this. Traditional kitchens rely heavily on manual paperwork and the chef's personal guesswork for portions and also the manual packaging. Through BPR, we transform these old methods into data-driven, automated, and integrated processes. Okay, this is the example how the workflow actually changes. First, the production planning is now based on AI demand predictions, not guesses. Second, raw material sourcing is done using real-time stock data. Third, storage temperatures are monitored automatically by sensors. Fourth, food portions are measured precisely using smart scales. And fifth, any production costs are reported directly to the central ERP system. To sum it up, VPR ensures that the new technology isn't just an expensive accessory slapped onto an old outdated system. Instead, VPR helps the company ensure that the technology drives real strategic and lasting change.
Okay, next we move on to the business continuity planning or BCP. So, what is business continuity planning? A business continuity plan is a strategy designed to ensure business operation can continue during and after disaster, disruption, or system failure. The purpose of BCP is to minimize operational interruptions and help organizations recover quickly from unexpected events such as cyber attacks, system failure, natural disaster, or network disruption. So, an important component of business continuity planning is the data backup and recovery. Data backup is the process of copying and storing important organizational data in secure location so it can be restored when needed. Organizations also use disaster recovery data center to recover and restore IT infrastructures when the primary system becomes unavailable. This recovery site can be categorized as the hot site, warm site, or cold site, depending on the speed of the recovery and available resources. In an AI and IoT-based central kitchen system, business continuity planning is essential because production operations rely heavily on integrated digital systems, real-time monitoring, ERP platforms, IoT sensors, and AI forecasting systems. Any disruptions to this system could affect production schedules, inventory management, food quality, monitoring, and customer deliveries. Therefore, the proposed system should include cloud-based data backup, disaster recovery procedures, secure network infrastructure, and real-time monitoring to ensure operational continuity. By implementing an effective BCP, large-scale catering companies can reduce operational risks, protect the critical business data, and maintain production activities, even during the unexpected disruption.
Okay, so now let's go to the sustainability in information system. Sustainability is based on three key dimensions, often called the three Ps, which is profit, people, and planet. The goal is to balance economic success, social responsibility, and environmental protection. In the catering industry, sustainability focuses on reducing food waste, improving energy efficiency, ensuring food safety, and supporting corporate social responsibility. To achieve these goals, companies can use AI and IoT-based information systems. These technologies help improve demand forecasting, optimize inventory management, monitoring storage conditions in real time, and reduce overproduction and food spoilage. As a result, companies can lower costs and waste, use resources more efficiently, improve business performance, strengthen their competitive and reputation, and support long-term business sustainability.
After discussing sustainability in information systems, we now connect the main concepts of this chapter: AI, IoT, and strategic information system. In a smart central kitchen, AI, IoT, and strategic information system, they support each other as one integrated system. IoT acts as the data collector. It gathers real-time information from cold storage rooms, production machines, and smart scales. The data collected by IoT includes the temperature, humidity, raw materials condition, energy usage, machine status, and food grammage accuracy. This data is important because central kitchen operations depend on freshness, hygiene, portion consistency, and production stability. AI then analyzes data to produce predictions and recommendations.
For example, AI can estimate our daily production needs. They calculate the demand of our raw materials, identify our risk of our overproduction, predict the possible machine problems, and help control food waste. And the SI system connects these technologies with the ERP, DSS, dashboards, and business process. This integration allows management to use operational data for faster and more accurate decision making. So, in overall, this relationship helps Lavienna Kitchen to transform from a conventional central kitchen to a smart central kitchen that is more efficient, accurate, and data-driven.
For example, IoT may detect that cold storage temperature is rising, while AI can analyze whether the raw materials inside are at risk of spoilage. The dashboard can then alert management and warehouse staff immediately so they can take action before the problem affects production quality. After understanding the relationship between AI, IT, and strategic information system, we'll move to chapter 3, which discusses the business case and purpose system for PT Nova Kitchen.
Alright, so Perencanaan Kitchen is a large-scale catering company that provides healthy and nutritious food to individuals, corporations, and institutions. Through its central kitchen, they produce thousands, even tens of thousands, of meal portions every single day. Because of this massive scale, they absolutely need operational processes that are fast, highly hygienic, and consistent. However, because their production is still largely manual, they face constant risk of food waste, production delays, and inconsistent food quality. To tackle these critical issues, this project introduced a strategic information system built on three technological pillars: AI, IoT, and automation. By integrating these technologies, we are creating a smart central kitchen. The expected outcome is clear. We will increase production efficiency, reduce human error, maintain high food quality, and significantly cut down both operational costs and food waste. Ultimately, this business requirement document serves as the core foundation for Petanova Kitchen's digital transformation, turning it into a highly competitive and sustainable business for their future.
After summarizing the main business problem and proposed strategy, we now explain the purpose of the BRD or the Business Requirements Document. The BRD is used as a formal guide for defining the business and system requirements needed to implement AI and IoT in PT Nova Kitchen Central Kitchen. The first purpose is to identify the key operational challenge, which includes the inaccurate demand forecasting, raw material waste, variation in food grammage, and limited real-time monitoring inside the kitchen. The second purpose is to define the system features required to solve those challenges, which include the AI-based demand prediction, IoT temperature monitoring, inventory integration, and management dashboard. The third purpose is to establish system QC, and the system must be secure, reliable, easy to use, and scalable so it can support daily production and future business growth. The BRD also creates a shared communication platform between management and the IT team. This is important because business needs must be translated clearly into technical requirements before implementation begins. For example, if management only says reduce food waste, the IT team may not know exactly what feature to build. A BRD makes it clearer by translating that goal into specific requirements such as demand forecasting, inventory alerts, and waste level reporting. After understanding the purpose of the BRD, we'll move to the business strategy which explains how the system supports PT Nova Kitchen's long-term direction.
So next, we will go to the business strategy. The company aims to build a large-scale catering business that maintains food quality, cost efficiency, food safety, and sustainability. To support this goal, PT Nova Kitchen implements an AI and IoT-based smart central kitchen. AI helps improve production planning and decision-making, while IoT enables real-time monitoring of operations that makes it much more easier for it to be a strategic information system. These technologies can help to create smarter, more efficient, and sustainable business operation. Next, we will go to the vision of PT Nova Kitchen. Their vision is to be the leading large-scale nutritional catering company in Southwest Asia, driven by reliable technology. Next, we'll go to their mission. The company aims to develop an AI and IoT-based smart central kitchen to support efficient, accurate, and integrated catering operations. It also focuses on improving the quality and consistency of healthy food products through standardized nutrition, portion size, and real-time monitoring. In addition, PT Nova Kitchen seeks to reduce raw material waste through demand forecasting and digital inventory management, while optimizing the use of resources such as labor, energy, equipment, and production time. The company also prioritizes food safety and hygiene through automated data-driven monitoring system. Finally, PT Nova Kitchen aims to build an integrated information system that connects all business functions and supports sustainability through operational efficiency, waste reduction, and green industry practices.
Okay, next we go to the goals. The goals are strategic objectives that the company hopes to achieve through the implementation of an AI and IoT-based strategic information system. In this project, Captain of Efficient's goals are build an AI and IoT-based central kitchen with an integrated information system. The next goal is to improve production efficiency through automation and optimize the resource use. Next is to increase demand forecasting accuracy using AI to reduce overproduction and shortages, maintain the consistent food quality, nutrition, and portion standards, reduce food waste through better inventory and production planning, improve food waste, improve food safety using IoT-based real-time monitoring, and support data-driven making through management dashboard. Okay, next is the objective. So the objectives are reducing the food cost by 30% within 18 months through better inventory control and waste reduction using the AI and IoT. Next is reducing the food waste to below 1% through accurate demand forecasting and optimized production planning. They also want to achieve at least 85% demand forecasting accuracy using the AI-based prediction models, and reducing the production and packaging time by 30% through automation of repetitive process, improve the portion and nutrition consistency to 95% using the smart weighting and digital controls. Next, they want to reduce raw material spoilage in cold storage by 50% with IoT-based temperature and humidity monitoring, and integrate the production, inventory, and financial data into an ERP system for better control and transparency. And lastly, provide a real-time management dashboard to support fast data-driven decision making.
Now, let's look at the business analysis. Before we design the system, we need to understand our internal and external conditions using two tools, SWOT analysis and Porter's 5 competitive forces. Let's start with the SWOT analysis to see where Petenova Kitchen stands. If we look internally, our biggest strength is our massive production capacity and centralized kitchen, which makes it very easy to control food quality and tap into the booming healthy food market. However, this big operation faces a major weakness. It is still heavily manual. Because we still rely on human hands for measuring portions, packaging, and checking temperatures, we constantly risk human error, inaccurate weight, and food spoilage. This is exactly where our external environment comes into play. Looking outward, we have a massive opportunity because consumer demand for healthy catering is skyrocketing. By injecting AI and IoT into our kitchen, we can perfectly capture this market, predict demand accurately, and cut down food waste. But we have to move fast because we also face serious threats. The competition out there is fierce. Customers can easily move to a competitor, and labor costs are also rising, and food prices fluctuate constantly. On top of that, going digital means we must also be ready to handle cybersecurity risks. So, our goal is to use our technology strategy to maximize our strengths, fix our manual weaknesses, capture the market opportunities, and protect the company from external threats. Now let's look at the competitive landscape using Porter's 5 competitive forces to see the real market pressures we are facing. First of all, the threat of new entrants is quite moderate to high because starting a basic catering business is relatively easy. However, scaling it up to match our level requires strict food safety standards and an integrated production system, which gives us a solid head start. This leads us to our suppliers, whose bargaining power is very strong because fresh food prices fluctuate constantly. To prevent this from ruining our margins, we need AI to predict our exact purchasing needs and IoT to ensure those ingredients never spoil. On the other side of the chain, both our buyer and substitute products present a high threat. Customers have strong bargaining power because they can easily switch to other healthy food options, restaurants, or even frozen meals. To keep them loyal, we cannot just rely on standard service. We must create undeniable added value. And finally, all of these factors intensify, intensify the and finally, all of these factors we face rivalry among existing competitors, which is already incredible fierce in the terms of price and quality. This is why our AI and IoT-based central kitchen is so critical. It isn't just an upgrade. It is our ultimate strategic weapon to drive down costs, eliminate waste, and secure our position as a market leader.
After discussing business analysis, we now move to the project definition, which explains the main structure of the proposed AI and IoT-based central kitchen project. This section defines the project more clearly before we go deep into the details. The project definition includes the project location, background, situation, objectives, the proposed project, the success criteria or the KPIs.
Now we will start with the project location because the location affects production efficiency, supplier access, and system implementation. The proposed project will be implemented in PT Nova Kitchen Central Kitchen in Tanjung Duren, West Jakarta. This area is considered strategic because it is located in an urban area and is close to business centers, residential areas, schools, universities, and commercial districts. This location supports catering operation because it provides easier access to customer, suppliers, and distribution routes. For a large-scale catering company, location is important because raw materials must arrive on time, and finished products must be prepared efficiently before delivery. The area also has supporting infrastructure such as road access, electricity, internet connectivity, and transportation facilities. These are important for implementing a smart central kitchen because AI, ID sensors, dashboards, ERP systems, and real-time monitoring all depend on stable infrastructure. The central kitchen will become main operational site for receiving raw materials, storing ingredients, processing food, packaging products, and connecting quality control or QC. Therefore, it is suitable for the first location for implementing the AI and IoT-based smart central kitchen system. For example, even the best forecasting system will not be effective if the kitchen location has poor supply access or unstable internet. In this case, Tanjung Duren is suitable because it supports both physical operation and digital system requirement. After explaining the project location, we will discuss background of PT Nova Kitchen and why the company needs a strategic information system. PT Nova Kitchen is a large-scale catering company that produces thousands of healthy meal portions per day. Because the production volume is high, the company needs an accurate and efficient system to manage customer orders, raw materials, production activities, social standards, and production costs. If the company continues to rely heavily on manual process, several risks may occur. Production planning can become inaccurate, especially when order volume changes or manufacturing increase. This may lead to overproduction, underproduction, delays, or raw material waste. Manual process can also affect food quality. In healthy catering, customers expect a consistent portion size, nutrition, hygiene, and freshness. If ingredient measurement and portion control are inconsistent, customer trust can decrease. Therefore, PT Nova Kitchen is a strategic information system that supports demand forecasting, inventory control, quality control, waste reduction, and cost efficiency. The system should help the company move from manual estimation to data-driven production management. For example, in diet or healthy catering, a customer may choose a milk package based on calories or nutrition targets. If portion size are inconsistent, the product may no longer match the promised nutrition standard, even if the food still tastes delicious.
At the current stage, within of a kitchen still faces several limitations in its operation. The first issue is that the production planning still depends heavily on the manual estimation. This becomes less effective when customer orders increase, the version of permanent become more complex, or the demand changes suddenly. The second issue is the cold storage monitoring. At present, the storage conditions are checked periodically by the staff. This means that our temperature and problems of humidity may not be detected immediately. If this issue is considered is too late, raw materials may already be damaged or unsafe to use. The third issue is the manual ingredient measurement, packaging, and portion weight control. And this creates the inconsistencies in our food quality, nutrition, and portion size. And for the healthcare catering company, this is a serious concern because customers expect the standardization. The fourth issue is that the production data, inventory records, and cost information are not yet fully integrated into one system. As a result, the reporting becomes slower and management may not have real-time information for decision making. For example, let's say if a cold storage is only checked every few hours, but temperature increase between checks can damage the ingredients without warning. But with the use of IoT, the system can detect the problem immediately and send alert before the damage becomes significant. Now, after identifying the current limitations, we'll explain the project objectives and what improvements the AI and IoT-based system is expected to achieve.
Okay, so now I will explain about the objective. So, the main goal of this project is to design and implement a strategic information system that optimizes the company's production process through the use of AI and IoT technologies. The project aims to improve production planning by using AI-based demand forecasting, allowing the company to better predict customer demand and prepare the required production capacity. It also seeks to reduce food waste and optimize the use of raw resources, helping the company operate more efficiently and sustainably. In addition, the system will ensure more consistent food quality, portion sizes, and nutritional content. Through the IoT sensors, the company can monitor storage conditions and raw materials in real time, helping maintaining food safety, quality, and the project also integrates production, inventory, quality control, and cost data into a single system. This provides managers with real-time dashboards and reports to support faster and more accurate decision making. Overall, the system is expected to reduce human error, improve operational efficiency, support sustainability initiative, strengthening the PT Nova Kitchen competitive advantage. Next, we'll go to the proposed project. So the objective of this project is to create a smarter, more efficient, and integrated central kitchen by combining AI, IoT, ERP, and automation technologies. The system includes several key components. First is the AI demand forecasting that helps to predict customer demand and production needs, allowing the company to plan production more accurately. Second, IoT cold storage monitoring provides real-time monitoring of temperature and humidity to ensure raw materials are stored safely. The system also includes smart weighing and portion control to maintain portion accuracy and consistency, as well as a production dashboard that provides real-time operational data for better decision making. In addition, ERP integration connects orders, inventory, production, and financial information within a single platform. To improve efficiency, the project incorporates automated packaging and labeling, while the quality control and traceability system helps monitor product quality and track raw materials throughout the production process. Overall, this system is expected to improve production planning, reduce waste and costs, to enhance food quality and safety, supporting faster decision making and increase operational efficiency. Next, we'll go to the project performance measurements or success criteria, or we call it as KPIs. Some of the main targets include achieving at least 85% demand forecasting accuracy, reducing food waste to below 1%, and lowering raw material costs by 20 to 25%. The project also aims to reduce production cycle time by 30 to 40% and maintaining portion accuracy of at least 95%. From a technology perspective, the system is expected to achieve 99% availability, fully integrated production, inventory, and financial data, and to provide operational reports in real time or within 5 minutes. In addition, customer satisfaction should reach at least 90%, while critical security incidents should remain zero. Overall, the project will be considered successful if it improves production efficiency, reduces waste and costs, maintains consistent food quality, enables faster decision making, and supports the company's sustainability goals.
So, to ensure this transformation is sharp and focused, we need to draw a clear line between what is included and what is excluded from our project at the Tanjung Duren Central Kitchen. Let's look at what is in scope first. Our main goal here is to optimize the core production process from the inside out. To do this, we are starting at the planning phase by implementing AI demand forecasting to predict daily meal volumes. Moving into the kitchen, we are installing IoT sensors in our cold storage to monitor temperatures in real time, alongside smart scales to guarantee exact food portion and stock ingredient weight. All of this real-time data, including quality control tracking and smart packaging data, will be fully integrated directly into the company's ERP system and displayed on a centralized production dashboard for the management team. And of course, to make sure this actually works, we include full internal user training for the kitchen, warehouse, and finance team. On the flip side, to keep the project from getting messy or expanding too far, we have set some very strict out of scope boundaries. We are currently focusing on the inside of the kitchen, which means we are not touching the external distribution, delivery fleet, or customer facing tech like mobile ordering apps and digital payment systems. And inside the kitchen, we are also not building a full human resource management system, nor are we buying full-scale cooking robotics or expanding to new branches outside West Jakarta. And lastly, while our system makes data ready for future food safety audits, obtaining formal external certification like halal is excluded from this page. By setting these clear boundaries, we ensure that PT Nova Kitchen can focus 100% of its energy on fixing its biggest priority, building an efficient, data-driven smart kitchen. Okay, finally, let's talk about the urgency and our timeline. Why do we need to do this now? So, the urgency is incredibly high because as PT Nova Kitchen scales up, our production complexity hits the roof. If we stick to manual processes, our risk of wrong portion sizes, food delays, and expensive ingredient spoilage will skyrocket. Plus, with fierce competition in the healthy catering market, the company that wins is the one who uses technology to cut costs and guarantee food quality first. We simply cannot afford to wait. And to make this transformation a reality, we have designed a realistic 18-month pace timeline to minimize operational risk. In the first 3 months, or in the phase first, we focus on the groundwork, analyzing business requirements, mapping our kitchen workflows, and gathering historical data. Month 4 to 6, which is in the phase 2, will be all about procurement, getting our IoT devices, smart skills, and network infrastructure ready. Then, from month 7 to 10 in phase 3, we move into software development, building our AI forecasting model, the management dashboard, and starting the ERP integration. And month 11 to 13 in phase 4 is when we get on hand installing the physical IoT sensors and smart scale for limited testing in the kitchen. Moving into months 14 to 16 in phase 5, we launch a system full scale across the entire central kitchen and run intensive training for our staff. And finally, the last 2 months in phase 6 will be used to evaluate our KPIs, fine tune the system, and finalize all documentation. By using this phase approach, we are not just rushing into tech, we are managing our risk gradually, allowing us to pivot and adjust to any operational challenges along the way.
Okay, so now let's go to the internal. The project involves several key departments within the company, each with specific responsibilities to ensure success implementation. Top management provides strategic direction, approves the budget, and acts as the project sponsor. The IT department is responsible for system development, ERP integration, infrastructure, security, and maintenance. The production department uses the system for production planning and monitoring daily operations. The warehouse and inventory team manage inventory data, tracks raw materials, and monitors IoT devices. The quality control department ensures food quality and safety standards are maintained, while the finance and accounting department uses system data for cost analysis and reporting. In addition, the nutritious and product development team ensure that menus and products meet nutrition standards, and the human resource department supports employee training and adaptation to the new system. Together, these departments ensure that the AI and IoT-based central kitchen is implemented successfully and can be effectively integrated into the daily operations. So now let's go to the part of the external. The project requires support from several external stakeholders to ensure successful implementation and operation. First, technology vendors provide IoT devices, sensors, smart scales, and technical supports. AI and software development partners develop the AI forecasting system, dashboards, analytical tools, and system integration. In addition, the ERP provider helps integrate production, inventory, purchasing, and finance data into one system. The project also depends on an internet service provider to ensure reliable connectivity for IoT devices and cloud-based monitoring. Raw material suppliers provide quality ingredients and support more accurate purchasing based on system forecasts. Furthermore, maintenance and technical support providers ensure that equipment and system operate properly. Regulatory and certification bodies help ensure compliance with food safety and quality standards. Finally, third-party logistic providers support the distribution and delivery of finished products. Together, these external stakeholders provide the technology, infrastructure, operational support, and compliance needed to ensure the successful implementation and long-term sustainability of the AI and IoT-based central kitchen.
After explaining the internal and external parties involved in the project, we now discuss how the business process in Pitinova Kitchen will change after implementing the AI and IoT-based system. In this part, we actually want to explain that the project is not about just the technology, but also about improving the way the central kitchen actually operates. Previously, many activities depended on the manual records, estimation of staff, and direct supervision. After the implementation, these processes are expected to become more integrated, digital, and data-driven. The manual records will be replaced by integrated digital system, so the production, inventory, QC, and cost data can be connected. And this reduces duplicate work and helps assess the same updated information. The experience-based estimation will also be improved through AI-supported planning. Instead of depending only on past experience, the production team can use demand forecasts based on historical data and order patterns. And then the IoT monitoring supports staff supervision by providing real-time information from the kitchen, especially for cold storage, equipment, and the operational alerts. This allows problems to be detected earlier. And then the ERP connects production activities with inventory and financial records, so that material usage and production costs can be updated more accurately. And then the management dashboards then summarize this information to support faster and better decision making. For example, in the old process, a supervisor may only know the final waste level after the production ends. But with the new digital process, waste trends can be monitored during operation, so corrective action can be taken earlier. After this overview of business process change, we will explain the primary business process change in more detail and compare the previous process with the new integrated process. Now, we're going to the main change. The main change is that the Pikinova Kitchen's workflow shifts from manual and separate activities into a system that is more integrated, automated, and data-driven. In the previous process, version planning depended heavily on manual estimation. And in the new process, AI forecasting supports production planning by analyzing order patterns and helping the team decide how many portions should be prepared. The raw material stock will also be connected to the ERP system. This means inventory data can be updated based on actual usage, so the warehouse and production teams can coordinate more accurately. The cold storage will be monitored using IoT sensors instead of relying only on periodic staff checks. The system can monitor temperature and humidity continuously and provide alerts when conditions become unsafe. Portion control will be improved through a smart weaving system, and this helps ensure that each meal follows the required image and nutrition standards. The quality control will become more digital and traceable. The inspection results, storage conditions, and production records can be documented in the system, which makes it easier to track problems when they occur. Cost reporting will also be updated in real time because production and material usage data are connected to ERP. This supports faster management decisions through dashboard. For example, if the dashboard shows that one menu is using more raw material than planned, management can investigate immediately whether the issue comes from the error version, inconsistency of receipt, or the inaccurate demand planning. After explaining the main process change, we are going to visualize the difference between the old process and new process through a graphical presentation. After explaining before, now this is the slide that actually visualizes the old process and new process. The old process shows that Pitinova Kitchen's production activities were mostly manual. Customer orders were recorded manually, portion and volume were estimated by the team. Raw materials were prepared based on those estimates, and the measuring, packaging, QC, and cost recording were mostly handled after or during production with limited system support. This kind of process can still work for small operation, but it becomes risky in large-scale catering because many errors can happen between stages. For example, production estimates may not measure real demand, the raw material preparation may be inaccurate, and cost reporting may only be available after the production is completed. And the new process is more integrated. Once the order data enters our system, the AI can analyze it immediately using the historical orders and predict the demand. The ERP will check the stock and the procurement needs, and then the IoT monitors the cost storage conditions, and the smart packing helps ensure the portion of accuracy. After that, packaging, QC, and inventory updates and cost reporting are connected digitally. The main advantage of new process is that each production stage generates data. This data will be used for the monitoring, evaluation, and faster decision making. So the system doesn't only record what happened, but it also helps the company control operations while they're happening. For example, in the old process, management may only realize that is too much material was used after reviewing the final report. But in this new process, the dashboard can show up normal material usage during the production, so supervisors can respond earlier. After seeing how these change, we will explain the performance requirements that the system must meet to support the large-scale central kitchen operations. Now, this slide explains that the system must be fast, accurate, and stable because it will support the high-volume food production of Lavienna Kitchen's demand. Lavienna Kitchen cannot use a system that is slow or unreliable because production activities depend on timely information. First, the system must be able to process daily order data quickly and generate production planning recommendations. This is important because production teams need accurate information before preparing the raw materials and assigning workers. Second, the AI forecasting system is expected to achieve at least 85% accuracy. This target helps companies reduce the overproduction, underproduction, and unnecessary raw material usage. Third, the dashboard must update production data, inventory levels, and cost sort conditions in real time or near real time. This allows management and supervisors to monitor operations while production is happening, not only after it's completed. Fourth, IoT sensors should send temperature and humidity data every 1 to 5 minutes. This supports faster detection of unsafe storage conditions and helps prevent raw material spoilage. And the system should also give automatic alerts for abnormal conditions such as low inventory, incorrect portion size, or unsafe temperatures. ERP integrations must update inventory and production costs automatically so the company can monitor both operational and financial performance. For example, if cold storage temperature rise above the safe range, for example, the safe range is 30 degrees Celsius. So, if it becomes 30 degrees Celsius, then we must detect it immediately. With the automated IoT alerts, the warehouse system can respond immediately instead of waiting for the next manual inspection. After discussing the system performance, the next slide explains the interface elements or how different users will interact with the system.
Okay, so now let's go to the interface requirements. The interfaces are designed to be user-friendly and provide relevant information for different departments within the company. The management dashboard helps management monitor key business indicators such as orders, production performance, costs, and food waste. The production dashboard allows supervisors to track production schedules, batch status, and completion times. The inventory interface is used to monitor stock levels, deliveries, and low stock alerts, while the quality control interface helps records and review food quality and hygiene inspection. The finance interface supports the analysis of production costs and cost efficiency. In addition, the system includes an IoT monitoring interface that displays real-time data such as temperature, humidity, equipment, status, and anomaly alerts. A mobile notification system also provides immediate alerts for critical issues, including low inventory, temperature fluctuations, and device failures. Overall, this interface helps users access information quickly, make better decisions, and reduce operational errors. Next, we'll go to the operational sustainability. The AI and IoT based system supports sustainability in several ways. First, AI demand forecasting helps the company match production with customer demand, reducing overproduction and food waste. Second, IoT monitoring helps maintain raw materials quality by tracking storage conditions in real time. Third, smart weighing systems improve portion accuracy and reduce unnecessary material usage. Finally, ERP integration helps the company monitor resource usage and production costs more effectively. The system also generates historical data that can be used to analyze demand trends, production efficiency, waste levels, and operational costs. This allows the company to continuously improve its operation. Overall, the system is expected to increase production efficiency, reduce waste, maintain operational stability, and strengthen the company reputation as a sustainable, healthy food provider. First, the project requires human resources, including management, IT staff, production teams, warehouse personnel, quality control staff, and finance personnel to support daily operation and system implementation. Second, it requires technology resources such as cloud infrastructure, IoT sensors, ERP system, AI forecasting tool, database, and security systems. Third, the system depends on accurate data, including order, inventory, production, cost, and quality data to support decision making and AI predictions. The project also needs reliable infrastructure, sufficient budget for implementation and maintenance, and user training to ensure employees can operate the system effectively. Overall, the success of this project depends not only on the technology, but also on quality data, skilled employees, and strong operational supports.
Okay, next we move on to the security requirements. The security requirements explain the measure needed to protect system data, devices, network, and operational processes. Since this system integrates AI, IoT, ERP, and dashboards, security risk must be managed carefully from the beginning. The system security requirements include the user authentication, which each user must have a personal account and authorized access right. The system should support the usernames, passwords, and ideally multi-factor authentication for user with sensitive access. Next is the role-based access control. Access rights should be assigned based on the user's roles. For example, the production team can only access the production schedules, and warehouse staff can access inventory data, and the finance team can access the cost information. Next is the data encryption. Important data such as the customer information, production data, supplier data, and financial data should be encrypted both during the storage and data transmission. Next, we have the IoT network segmentation. The IoT device this should operate on a separate network from company's main network to reduce the security risk if a device experiences failure or cyber attacks. Next is the audit trail. The system should record user activities, data changes, report access, and collect corrective action taken in response to system notification. Audit trails are important for accountability and investigation purposes. And we have the backup and recovery. The system must support regular data backups and provide recovery procedures in case of system failure, data loss, or server disruption. And the last one is the security monitoring. The IT department should regularly monitor system and network activities to detect unauthorized access, anomalies, or security threats. These security requirements are important because system disruption can affect not only the company data but also the food production process directly. Next, we move on to the availability requirement. So the availability requirement describes the level of system availability needed to ensure the central kitchen operation can continue without disruption. Since the system supports daily production activity, high system availability is essential. So for this project, the availability requirements include the main system should maintain at least 99% availability during production operating hours. The production, dashboard, and IoT monitoring system must be accessible to internal users throughout the production process. Next, IoT sensors should continuously send data and provide notifications if device failure or connection problem occur. The system should include backup servers or cloud backup solution to reduce the risk of data loss. The company should also provide a backup internet connection to ensure system operation continue if the primary connection fails. For the critical processes such as the cold storage monitoring, the system should still operate through a local network even if external internet connection is unavailable. The company should prepare temporary manual procedures in case of system downtime so that production activities can continue during emergencies. These availability requirements are important to ensure that dependence on the digital system does not create additional operational risk that could interrupt production activities. Next, we go to the legal requirements. Legal requirements describe the laws, regulation, and compliance standards that must be considered during system implementation. In the catering industry, legal aspects are related to the food safety, data protection, hygiene standards, labor practices, and product labeling. So for this project, it includes for the food safety. The system should support the recording of food safety data such as storage temperature, raw material quality, production time, and quality control results. This data can be used as evidence of quality management and food safety compliance. Next is the nutrition labeling. As the company operates in the healthy catering industry, nutritional information on product labels must match the ingredients and recipe standard. The system should help ensure that portion sizes and nutrition data are recorded accurately. Next is the data protection. Customer data, transaction data, supplier information, and operational data must be managed securely. The system should limit unauthorized access and maintain the confidentiality of business information. Next is the production hygiene standard. The production activity must follow hygiene, sanitation, and food safety standards. A digital quality control system can support monitoring and recording compliance with this standard. Next is the audit compliance. The system should provide historical data and reports that can support both internal and external audit, especially for raw material, production process, packaging, and product quality. And the last is the use of devices and vendors. The company should ensure that all IoT devices, software systems, and cloud services used in the project have valid licenses and clear service agreements. Meeting the legal requirement can help the company reduce the legal risk, protect its reputation, and increase customer trust in its product. So we next go to the other requirements. In addition to the main requirement, there are several additional requirements that should be considered to ensure the project is implemented effectively. The first one is the change management. The company should prepare a change management strategy because the implementation of a new system will affect employees' work process. Socialization, training, and user support are important to help employees adapt to the new system. Data governance. The company needs clear policy regarding data ownership, data input standards, data validation, data quality, and the responsibilities of each department in managing system data. Next is the scalability. The system should be designed to support future expansion, such as adding new central kitchen branches, integrating additional IoT devices, developing custom applications, or connecting distribution systems. Move on to the maintenance plan. The company should have a maintenance plan for software, IoT devices, networks, and databases. Regular maintenance is necessary to keep the system stable, secure, and accurate. Next, we go to the user acceptance testing. Before the full implementation, the system should be tested by internal users to ensure that all features meet operational needs. The testing result can be used to improve the system before the launch. Next is the documentation. All system processes, configuration, workflows, user guides, and emergency procedures should be properly documented. Documentation is important for training, audits, and future system maintenance. Continuous improvement. After implementation, the company should regularly evaluate the KPIs and collect user feedback. This process helps improve system performance, increase AI accuracy, and adjust system features according to changing business needs. By considering these additional requirements, the AI and IoT-based central kitchen project can be implemented more effectively and specifically. The system will not only meet technical requirements but also support long-term business growth and digital transformation.
Okay, since our smart kitchen depends heavily on digital system, we must ask what happens if the system goes down. The central kitchen is our main production engine. If the power cuts out, the network drops, or the database crashes, it directly leads to production delays, ingredient spoilage, financial losses, and lower customer satisfaction. BCP is our safety net to ensure operations never stop. That is exactly why we need BCP. Our main objective here is to make sure that large-scale catering production never stops, even during a major technical failure. To break it down, our BCP focuses on four specific goals. First, operational continuity. We want to ensure the kitchen can keep cooking through alternative backup procedures when the AI, IoT, or ERP systems are temporarily unavailable. Second, the food safety. We aim to minimize raw material spoilage by having immediate backup plans if the cold storage cooling system or sensors fail. Third, data security. We must ensure that all production, inventory, and cost data are securely backed up and can be recovered instantly if a data loss occurs. And finally, fast recovery. We want to reduce downtime as much as possible to protect our operational costs, company reputation, and customer satisfaction through fast, structured recovery processes. In short, BCP is our safety net. It ensures that while technology drives our efficiency, human and operational backups will always protect our business sustainability. Okay, now let's discuss our critical business functions. There are the core operations at Perencanaan Kitchen that we must protect at all costs during a disruption. To make it easy to follow, they flow in a straight logical line from the kitchen to the office. It starts with the planning phase, production planning and raw material management, which decide what and how much we cook. Then it moves to the physical execution, both storage, monitoring, and the cooking and packaging process, and also the quality control, which ensure our food is safety, accurate, and delivered on time. And finally, it connects to the system layer, ERP recording, dashboard monitoring, and data backup, which keep our numbers and data visible to management. If any of these links break, our entire operation stalls. That is why they are our highest priority. To protect these functions, we have mapped out 10 specific risk scenarios in our paper. For this presentation, let's look at the big picture of how we group and mitigate them following the exact flow of our system. First, infrastructure risk. This covers everything from power outage, internet drops, server crashes, to broken sensors and cold storage. Our main defense here is hardware redundancy, meaning we provide backup generators, secondary internet lines, mirror servers, and backup sensors to keep the physical kitchen running. Second, software and system risk. This includes AI forecasting failures and cyber attacks. If the AI acts up, we instantly drop back to manual methods using historical data, and we secure our network using firewalls and encryption. And third, human and external risk. This covers human error, supplier delays, and local disaster. We handle this through strict procedures, specifically continuous staff training, maintaining a safety stock with alternative suppliers, and setting up emergency recovery plans. Ultimately, this proves that our business continuity doesn't just rely on the technology itself, but on a ready combination of backup hardware, clear manual procedures, and trained human resources.
Okay, now I'm going to explain how PT Nova Kitchen can still maintain its operation even though electricity or infrastructure problems occur. The AI and IoT-based digital kitchen depends heavily on stable electricity. Power is needed not only for production equipment, but also for cold storage, audio sensor, servers, network device, smart learning system, and production dashboard. And because of this dependency, backup power becomes a critical requirement for them. If the electricity fails and there is no backup system, the cold storage may stop working, the temperature monitoring may be interrupted, and production data may become unavailable. And this can directly affect the food safety, production continuity, and raw material quality. The first strategy is to provide UPS system for important devices such as servers, network equipment, IoT device, and dashboard. UPS helps keep system running temporarily during short outages or while the generator starts. The second strategy is to use automatic generators during longer power failures. The generator should prioritize critical loads, especially cold storage, servers, universal servers, systems, and temperature monitoring. The company should also test UPS systems and generators regularly. Backup systems are only useful if they work properly during an actual emergency. A priority list for critical electrical loads should also be prepared so the company knows which systems must remain active first. Overall, backup power helps reduce the risk of production shutdown and protects the central kitchen operations during power disruption. Let's say an example. If the cold storage loses power for 7 hours, the ingredients such as meat, dairy products, and prepared sauce may become unsafe to use. In that situation, the company may lose raw materials, delay in production, and risk of food safety. And backup power helps prevent this chain reaction. Now, after explaining about the backup power and infrastructure continuity, we will discuss the network and data continuity. After discussing the backup power and infrastructure connectivity, now we move to network and data continuity. This ensures that the digital system can still support operation during the problems of connectivity. The AI and IoT-based attraction depends on a stable network because the sensors, dashboards, ERP systems, database, and user device need to exchange information continuously. If the network fails, real-time monitoring and system coordination may be interrupted. One strategy is to use an internal local network for IoT and production system. This allows a more critical monitoring activities such as the trackers of the cold storage temperature to continue even if the external internet connection is disrupted. The company should also provide backup internet from a different service provider. This reduces dependency on one provider and helps maintain system access when the main connection is down. The critical data should be stored locally when cloud access is disrupted. After the connection returns, the system can synchronize the local data back to the cloud. This prevents data loss and helps maintain accurate operational records. Regular automatic data backups are also necessary. These backups should be stored in secure separate locations or cold storage, so the company can recover important data even if the main system fails. Finally, the company should set the RPO and RTO targets. The RTO defines how quickly the system should recover, while RPO defines how much data loss is acceptable to the company. These targets help company prepare the clear recovery standards for the company. For example, if the internet connection fails during production, the kitchen will still be able to access latest order data, monitor cold storage, and record the material usage locally. Once the connection returns, the system can update the central database automatically. Now, after explaining about this network and data continuity, we will discuss the manual fallback procedures. Okay. Manual fallback procedures are procedures for situations when the digital system cannot be used temporarily. Even though GPT Notification plans to use AI, IoT, ERP, and dashboard, the company still needs the manual backup procedures. This is important because production must continue even though there is system failure, network disruption, or the technical product problem. The first procedure is to use the latest printed or locally stored order data. This allows the production team to continue preparing meals based on the most recent available information. The second procedure is to use manual production planning templates. So if AI forecasting is unavailable, the professor can still estimate production needs using the previous predefined forms and historical reference that actually happens in the past. Cold storage should also be monitored using the backup thermometers when anti-sensors or dashboards are not available. This ensures that the conditions of our raw material can still be checked manually. Now, the raw material usage, production results, and food waste should be recorded manually during downtime. After the system returns not to normal, data must be reintegrated into the ERP system so inventory and cost records remain accurate. The printed receipt standard should also be available to maintain production accuracy and gradient consistency. So during the emergencies, supervisors should act as key decision makers to coordinate production and reduce confusion. Overall, the procedure ensures that the cooperation can continue at the minimum acceptable level even when our digital systems are disrupted. For example, if our ERP system is not available during morning production, the team can still use the printed order summaries, receipt sheets, and manual stock forms to continue the production. This prevents the kitchen from stopping completely while the IT team works on the recovery.
Important to ensure that all parties understand their responsibilities and that responses can be carried out quickly and in a coordinated manner. The phase of incident response in this project are as follows. First is the detection. The system or users detect a disruption, such as sensor failing to send data, inaccessible dashboards, unstable cold storage temperature, or unresponsive ERP system. Next is classification. This disruption is classified based on its level of impact, such as low, medium, high, or critical. Critical incidents are those that may stop production activities or damage raw materials. Next is the escalation. The issue is reported to the responsible parties, such as the IT teams, production supervisors, warehouse staff, quality control team, or management. The next one is the containment. The responsible team takes immediate action to limit the impact of the disruption. Examples, including moving raw materials to backup cold storage or activating manual operation procedures. The next one is the recovery. The affected system or processes are restored to normal operation. Recovery actions may include restarting servers, replacing sensors, restoring databases, or activating backup network connection. Next is the post-incident review. After the incident is resolved, the company evaluates the cost, impact, recovery time, and corrective action to prevent similar disruptions in the future. With a clear incident response plan, the company can reduce the impact of disruption and restore operation more quickly. And the last is the roles and responsibilities. The success of business continuity planning depends on clearly defined roles and responsibilities. Each department must understand its responsibilities during operational disruption. So here are some of the parties and their responsibilities. So the first one is the top management. The responsibility is to make the strategic decision, approving the CBP activation and determining recovery priorities. And the next one is the IT department. They responsible for the handling system, network server, database, backup, cybersecurity, and recovery issues. As for the production supervisor, they are responsible to manage the continuation of production process and activating manual procedures if necessary. For the warehouse team, they are responsible to monitor raw material stock, cold storage condition, and taking action to move materials if needed. The quality control has the responsibility to assessing the feasibility of raw materials and products after a disruption. Next is the finance and accounting. They are responsible to ensure that costs research and transfer remain documented. For the next one is the HR department, which are responsible for managing internal communications, emergency training, and human resource repression. And the last is the vendor or technical support. They are responsible to provide technical assistance for IoT devices, ERP networks, or software systems. So clear distribution of responsibility help prevent confusion during incidents and speed up the recovery processes. And next we go to the business continuity strategy. The business continuity planning or BCP strategy at the pattern of a kitchen is designed based on the principle of high redundancy, local resilience, and fast recovery. High redundancy means the company provides backup for critical components such as electricity, network, sensors, and data. Local resilience means that the system can continue operating through the local network even if the external internet connection fails. Fast recovery means the company has clear procedures to restore systems and operation in a short time. So the BCP strategies implemented in Nova Kitchen include the providing UPS system and automatic generators to maintain power supply in critical areas, using internal local network to maintain communication between IoT devices and core production system, providing backup internet connection from different service providers, performing regular and automatic data backups, preparing manual SOPs for production activities, temperature monitoring, inventory recording, and quality control, providing backup devices for IoT sensors and smart weighing systems, implementing cybersecurity controls such as firewalls, network segmentation, role-based access control, and audit trails, conducting the regular BCP simulation to ensure team readiness, involving the vendors in technical support and maintenance agreements, and performing post-incident evaluation to improve system and SOPs. These strategies ensure the company can not only respond to disruptions effectively, but also maintain critical operation while disruptions are occurring. Okay, next we go to the recovery target. The recovery targets are used to determine the acceptable recovery time for systems and the maximum level of data loss that the company can tolerate. These targets are important for helping the company prioritize the system recovery during disruption. Here are the table for the system or the process. The first row is the system or the process. The second one is the RTO, and the third one is the RPO, and the last one is the priority. So for the cold storage monitoring, the RTO is 15 to 30 minutes, and the RPO is maximum 5 minutes data loss, and the priority is verified. The dashboard production, the RTO is 1 hour, the RPO is maximum 15 minutes data loss, and the priority is high. Next is ERP inventory and production module. The RPO is 2 to 4 hours, and the RPO is maximum 1 hour data loss, and the priority is high. Next is the AI demand forecasting. The RPO is 24 hours. The maximum of the RPO is 1 day data loss, and the priority is medium. Next is finance reporting, which has the RPO of 24 to 48 hours, with the RPO of maximum 1 day data loss, and the priority is medium. And the last is the historical analytics, with the RTO of 48 until 72 hours, with the RTO of maximum 1 week of data loss, and the priority is low. So the BCP should be evaluated at least every 6 months or whenever there are major changes in the system, business process, vendor, or central kitchen infrastructure. With regular evaluation, the company can ensure that the BCP remains relevant and effective in facing the operational. And next is the conclusion of business continuity planning. The business continuity planning in AI and IoT-based central kitchen project is an important component to maintain the continuity of production at Nova Kitchen. Dependence on digital system provides many benefits, but it also creates risks that must be managed systematically. By providing backup infrastructure, data backup, local networks, manual procedures, incident response plan, and clear recovery target, the company can minimize the impact of disruption on the production process. BCP also supports the company's strategic goals in maintaining product quality, reducing the risk of losses, maintaining customer trust, and ensuring the digital transformation can proceed safely and sustainably. Okay, we go to the technical implementation of AI and IoT at PT Nova Kitchen. To achieve the target of reducing food cost by 20% and improving operational efficiency, artificial intelligence and IoT are not used separately. Instead, both technology are integrated with the company's ERP system. This integration helps PT Nova Kitchen manage production, monitor inventory, and control costs in real time. In a central kitchen business, accuracy is very important. The company must know how many portions will be ordered, how much raw material is needed, how much is actually used, and whether there is any waste during the production. Without digital support, these processes are often handled manually and may cause errors, delays, and higher costs. For this reason, AI and IoT provide a practical solution to support both operation and accounting. Okay, now we will discuss about the artificial intelligence or AI for demand forecasting and production optimization. So Petenova Kitchen uses an advanced machine learning framework such as the random forest or ASTM algorithm to handle two main tasks. The first one is predicting customer demand. The AI system automatically studies 6 months of historical order data. It combines this with external factors like the weekly patterns, public holidays, and current healthy diet trends. For example, if the data shows that order for low-calorie chicken breast always spike by 15% on the Monday after a long weekend, the AI will automatically scale up production for that day. Next one is for smart receipt and portion scaling. The system targets a forecasting accuracy of at least 85%, and if the AI predicts a demand for 1,000 specific diet meals tomorrow, it instantly breaks down the exact raw ingredients needed. Like, for example, they forecast that it needs exactly 150 kilograms of chicken breast and 50 kilograms of broccoli. This stops over purchasing and prevents food waste before production even begins.
Now we will move to IoT, which supports real-time operational control inside the central kitchen. IoT works as the real-time monitoring system in PT Nova Kitchen's operation. The first application is automated cold storage tracking. Smart temperature and humidity sensors are installed in freezers and coolers to monitor storage conditions continuously. The target temperature is around minus 18 degrees Celsius, which is important for maintaining frozen raw materials and preventing spoilage. If a cooler door is left open or a compressor fails, the system can send an instant alert to responsible staff. This allows the warehouse or production team to respond quickly before raw materials become damaged. The second application is smart weighing scales for grammage control. Digital scales send ingredient weight data directly to the ERP system. This helps ensure that the portion size and nutritional accuracy remain above 95%. It also reduces manual logging errors and makes financial records more accurate because the system records actual amount of ingredients used. Overall, IoT support better control, faster response, reduced waste, and more accurate production records. For example, if a refrigerator door is accidentally left open after receiving raw materials, staff may not notice it immediately in the manual system. But with IoT sensors, the system can detect the temperature change and send an alert before the ingredients spoil. After explaining the technical implementation of IoT, we'll move to chapter 4.
Now, in chapter 4, we close the presentation with the conclusion and recommendation. So the conclusion is that AI and IoT-based information system can help within a kitchen improve efficiency in large-scale catering production. The proposed system addresses the key operational problems such as the inequality in demand prediction, raw material waste, inconsistent portion size, and limited real-time monitoring. AI plays an important role in demand prediction, production planning, and database decision-making. With AI, the company can estimate production needs more accurately and reduce the risk of producing too much or too little. IoT supports real-time monitoring of search conditions and portion control. This helps the company maintain raw material quality, detect storage for failure, and keep food portion consistent. When AI and IoT are integrated with ERP, dashboards, and QC system, the company can improve inventory management, reduce waste, and support faster managerial decisions. The conclusion also emphasizes on the business continuity planning because the system depends on digital technology, backup power, data production, and manual product processors.
So now let's go to the next slide, which is recommendation. So this study helps us understand how strategic information system combined with AI, IoT, ERP, and production optimization can improve business operations in the catering industry. It shows how technology can increase efficiency, improve product quality, and create competitive advantages. The study also highlights important implementation factors such as data management, human resource readiness, system security, and business continuity. Finally, it can serve as a useful reference for future research on digital transformation and information system. Okay, so here are all the references that we used to make the presentation and paper. Thank you for listening to our presentation, and we hope that the material would be useful for all the listeners.